Hello, this is James from xrobots.co.uk and this is part 5 of Android 12. So I'm working on the hips for Android 12, which is this assembly here. If you have a look at the website, xrobots.co.uk/Android 12, you can see the CAD pictures and the pictures of the individual pieces. But basically, what we've got here is two halves of the hips. So the thighs will hinge here in this direction. They can move this way, so the Android can lean from side to side. That's symmetrical. And then basically there's two holes you can see just there, so that the legs can move this way, and basically it can move its feet apart so it can walk in circles or turn on the spot. This assembly sits in the base. You see it's got a stopper for each half to rest against, and the holes should align. And there's also a top plate, which is this piece with one more servo in, and that piece fits on there, and the holes should align again, and then the servo is to basically push these pieces apart. So it'll become a bit clearer once I've assembled that. The holes which are left, normally I'm using M6 studding, those holes are M8. So I've got these ½ metre pieces of M8 studding, which should go all the way through there, all the way down through the pieces, and they'll be bolted solid to the top and the bottom plate, so these are free to rotate based on nuts and washers. And then these long pieces will continue all the way up the Android to make the spine. So for now the spine is going to be totally rigid, although depending on how the upper body design goes, they might get cut, and then there'll be an extra rotating joint that allows the body to swivel. First of all, I'd just like to get the Android walking along so I can attach some ballast to simulate the body weight to the spine, and then we can sort of do some crude testing. One of my least favourite tasks is winding on lock nuts. I always use lock nuts basically because they lock and they stay in place, so they don't wind up with the movement of the pieces. As you can see, I've got a load of lock nuts and washers in these pots. That's full of M6, that's full of M8 and M8 washers, which I bought hundreds of from Screwfix years ago for Android building, probably coming up to 10 years ago. And as you can see, I've used hardly any of them. So anyway, let me wind that on. So that's one half on the bottom plate. So you can see it rotates like that. It doesn't rotate a great deal, but doesn't really need to if you think about the foot sticking out, how much it can actually move, and obviously the other one can move the same. So it's not going to do break dancing or anything, so just to turn on the spot, that'll be fine. So I just need to do the same with the other side and put the top plate on. Okay, so here are the parts together. That splits apart there. I've got a couple of springs that I've just placed in there to hold it together for now. The servo here will have rods that push in opposite directions to push those two pieces apart, and that will obviously split the legs. I need to make some custom servo levers, which I'll probably 3D print to come off these servo horns, and obviously that allows the Android to lean from side to side. And then the legs will be hinged onto these brackets here with the what effectively will be the muscles pulling back and front here. So let's get these things attached and this thing sorted out, and then that will conclude the thighs, the hips. So here's my custom servo lever. There'll be a pair of these. I've designed this in Autodesk 123D, which is free software, as I have with all the parts. And the parts will be printed on my Lulzbot 3D printer. If you want to know more about the actual 3D printing, you can look at xrobots.co.uk/3D with an uppercase D. So let's get that printed and attached to the hip assembly and see how that works. So I decided not to bore you with another video of a 3D printer making parts. There's plenty of that in my channel already, but I've printed the parts. There's one either side, and obviously those allow the hips to move, so they're levered up quite a bit, so they're right on sort of halfway up that servo horn, which should be enough movement. And if it's not enough movement, I can move the levers out slightly, but that should be fine just for shifting weight side to side. There's one of those on both sides obviously, so we can you know, lean the legs in the same direction, and so on. So I've put the servo horn on here, which will, as I said before, have rods that push these apart, and there's a couple of holes there you can just about see for that. I'm not going to make that part just yet. For initial stability testing, I'll probably just cable tie these two together so they don't split apart. And once the android's in motion and I want to try and make it turn, then I'll put that lever in. I'm not quite sure how it's going to look at the moment, whether it's got 3D printed parts or whether it's going to have you know, metal parts. I think there's going to be quite a bit of force pushing that whilst it's standing on one leg. So for now I'm going to leave that part and come back to it when the android can actually walk. So that's the end of this video. The next video will be about making the thigh mechanism. So the top of the legs are bare at the moment above the knee, so I need to make the thigh with another servo and then another hinge mechanism that holds shock absorbers, and then the bracket that actually hinges that onto the bottom of here. So here are all the parts of the android together in one piece. I've just basically propped the body on the legs and attached the legs together with a clamp and a ruler. So far that is just coming up a 1m10 tall, which is about 43 inches. So the finished height is going to be about 130, which is 51 inches, which is sort of roughly chest height to a normal person. So as I say, next time I'll be working on the thighs, so look out for the next video.